Hey there, how's it going? In this video I'm just going to go through the steps for basically using sorting technique in Spark in some like data. You may have some data that you have to work with, and that data is causing skewness, and maybe it's basically slowing down your Spark job. So I think sorting technique is one of the most preferable technique to solve data skewness in Spark. So I'm just going to go through the steps that you can take to implement sorting technique within your code. So as you can see here, I've got two data that I will be joining together, and two data frames, right? So the first data frame is this one. It has a product ID, country, price, and year. And the second data frame is this one. It has the ID which belongs to the product and the product name. So what I want to do is join this data frame, the product data, with the first data frame that has the country information, the product price, and the year. Probably year turnover for that particular country. So okay, moving on, without further ado, let's get started into the coding. So what I need to do first, so as you can see here, I've set the number of partitions that I want, which is 4. And you can just ignore this. This is just because I don't want some log on the console while the job is executing. That's why I put this one here. So, and the next thing I need to do is basically get the partition number. So if I say if I come here and say var partition equal to spark.conf.get, so that would be spark.shuffle.partition, and so I want to get this should be Spark session, not Spark, because I already defined a Spark session here, right? So now I can get the partition, right? Partition, and so if I print it out, it's going to print 4 as a string, but I want to get it as integer because I'm going to be using it as integer later. So I have to convert it to int, and then so before I apply any sorting method, I want to show you how this if I do joining on these two data frame, I want to show you the duration on the Spark UI, like the time it's going to take to execute. I want to show it to you, and then later I will do sorting. Then you can see the time comparison between the two. So the first thing I'll do is let me save join df equal to, so this will be my left table producer df dot join. So I want to join the product df products, which is product data frame. So I want to join with the ID, so producer so producer df.call. The column name is for this one, okay, so the column name for producer df is the one is it's product ID. That is the one I want to join, product ID. And then so if the product ID equal to product df.call, the column name is the ID, which is the product ID. So the join type is going to be left outer. I just choose left outer. Well, you can choose inner or any other join type. Left outer. And then so if I show the data frame, right, join df.show, so I'm not going to show show the output now for comparison. I'll just keep going until I finish the code. So I'll leave that one there. So the next thing I want to do is what I want to do is basically check the partitions. I mean, we've got 4 partitions basically, but I want to see if each of those partitions has data within them, because actually we want the data to be evenly distributed. So okay, let's do that. Join df dots. So I want to group it by the ID, group by products ID, right? So then aggregate, I want to basically count it, and so aggregate counts, the column name is going to be product ID, yeah, products ID. So dots as counts. So change df the group by, okay, let me give this one a name of counts df by, so count df. Now I can display counts df, right? I can display counts df dot show, right? And so the next thing I want to do is basically, as I said earlier, I want to find the partition. So I'll say count df, count df now, right? Count df dots for each partition, and then so for each partition I want to, okay, the data type is going to be iterator and need row method. So I want to print, so what I want to print is I dot to let me do to size, I dot to list, yeah, to list dot size. Okay, I'm going to execute this now, and so as you can see here, this is product ID 103. It has 15 record, 104 has 14, 102 has 9, and as you can guess, 101 is going to take longer to execute, right, because it's got 106 methods. So I can go to Spark UI right now. So if I go to Spark UI, and this is the Spark UI. So let me check where we are doing for each. This is count area, so number 29, line 29, I mean, sorry. So line 29, if we check. So I mean, we should have like, we should have 4 partitions. I think there is some issue. One of the partition is not having any data. So that is the thing that can happen. We have like so many partitions that the data will be distributed, but some partitions we don't have enough data. So your job end up taking much time. Alright. So as you can see, we have this one taking 39 milliseconds, this one is taking 45, and this one is taking 21. So so let's go back to the code. Let's see which of these partitions is not having data. Okay, you can see the first one is not having any data, because here we are basically counting. We are basically like printing each partition basically. So if I delete this size, right, and just print list, you will see that one of those partitions is not having data. This one is not having anything, and that is not what we want. So the last partition is having 103. I mean ID, product ID 103, and if you see here 103.15, right, and it's also having 104.14 and 102.9. So also you can use join df here to see what is going on instead of count df. You can use join df. So okay, it's going to, I want to print the size, but size. So as you can see, we are having the number of partition is 1. So that is why we have this size 144. But the thing is, if you order this join df by the product ID, right? Order, let me see. Okay, order by dots, order by products ID, and then you can just drop the ID, because product ID and ID are the same. Drop ID. So you will not have this 144 because we will have like different partitions, because we are basically ordering that join df by the key. So each key will belong to different partitions. Is this? So as you can see, we are getting the same thing as we get here, 15.49106. So so it's still the same thing. So we have like 4 partitions, and this will be taking longer. Yeah. So now moving to sorting. So what I'll do here, I'll define a var sort, sort equal to so we basically want to generate random numbers first using the partitions. So our partitions currently is 4. By default Spark partition is 200, but you can set the partition depending on the data you are working on. So okay, so what we do here is use for method for, then random, which is like round. We want to multiply it by the number of partition, because it's going to start from 0, right? We're going to multiply it by the number of partition minus 1. Partition minus 1. Okay, there we have our sort, right? Or just random method from 0 to 3, because our partition is 4, so that will be easy from random number from 0 to 3, right? So the next thing I'll do is define a data frame that we have that sorting random number. So the data frame will be, let me call it sort df. Sort df equal to so that will be producer, because producer is our left table, right? Producer df dots with column. So let me call this column sorting, maybe, yes, sorting, or left sorting, left sorts. So what I want to do is concatenate the ID here, this product ID, with underscore, then the random number. So I will use concat method. By the way, you have to import all this method I'm using, right? I will use concat, and I'm going to use late, I'll use one, so you have to import all those methods. So concat the product ID, so that will be called product ID, and then so that's called let's underscore. So because we want to join them like by random key, right? So and then so the random key will definitely be let's sort, right? Okay, so I can show you the sort df so you can see what is going on. I'll show, let me say 200, just to show you everything. Okay, now we have the our sort df printed. So you can see, right, we have a 101 underscore 0 underscore 1 underscore 0, so it's just generating those number randomly. 103 underscore 2 104 underscore 2 104 underscore 1, so it's just generating those number randomly, right? So so if we are going to join this one, okay, first of all, what I'll do is I'll show you the counts just like we did here without any sorting, right? Okay, to show you the counts, let me say var sort count df equals to so that would be sort df dot group by. I'm going to group it by it's not going to be product ID because we have sorted applied sorting technique basically on the right data frame. So now we have to use left sort instead of using the product ID. Left sort column, then I'm going to basically use aggregate method, then count. I want to count the basically this sort left sort sort. Okay, so as counts, okay, so I'm going to display a sort counts df.show, and then I'm going to print the number of partition sort counts df dot for each partition, right? And I'm going to okay. So be print line and I dot to list. Yeah, I dot to list. I'm not printing the size. Just to compare everything. Count df. Okay, to list. Alright, so we have to do comparison between this new data frame with the previous one. Okay. Okay, now guys, you can see right here in the first place, right, we have basically the counts of product ID and the yeah, so basically we have the counts, the product ID, which is 106 9 14 15, and the second count here we have now, because we don't have only 4 keys, we've got like different keys here, right? So 101, like 101 underscore 2 is now has 43 records, and 101 underscore 1 has 28 records, and you can see that 101 is no longer having like 106 record. You know, it has divided into different keys, and it has 43 record, 35 records, and also 28 record here. The same thing applies to the other keys. But if you want to do that for 101 alone, I think you can do it. You can just leave other keys alone. But here I'm just doing everything together. So another thing is when we print the counts, here we have one of these lists is having nothing. Let's check if the same thing happened after we've done the sorting. Apply the sorting. You can see all the partitions are having basically the data within them, so it's not, there is no empty partitions. What you can do, basically, you can try to, you know, use queries or repartition, basically, to repartition the data. So I think yeah, I'm going to take some time to do. I'm just going to so what I can do is basically show you the UI. So here, right, for each partition here we have 40, right, line 14, and here we have line 31. Let's compare the execution time of Spark UI. So I think 14, right, the execution time is 0.1 second, I guess. So so we have this one taking this is 32 milliseconds, 41 milliseconds. The one that take more time is 96 milliseconds, but the overall time is 0.2 seconds. And if we go back to so we can say check the one number 31. I think that is where the first one is for each partition. So this one is also taking 0.2 seconds, but there is not much significant difference due to the data number that we have, I guess. Okay, moving on. Let's see. Okay, so what I'll do next is basically do the joining, just like we did without the partition. Let us now do the joining with partition. Now, what I can do is basically explode a range of number from 0 to 3, because we have our partitions random number generated from 0 to 3 as well. So we need to generate this record as well for the second table. So I'm going to define it, let me call it right df equal to, okay, so that will be products df dot with column, and then I'm going to call it exploded code. So what I want to do basically, as I said, is basically explode an array from 0 to 3. So I'm going to write explode method here. Explode array. So the array is going to be from 0. So I'll say 0 until the number of partition. So that should be from 0 to 3, right? And then so let me give this one a, okay, put in parentheses, then dot map. So that will be leads underscore, or just for you to understand, I could use I dates I. Then so I want to basically put them in array, right? Each of these data. So I'll say let's see, okay, use colon underscore asterisk, so that will put them in the array. And then so that is exploding them, we put them in the array. Okay, yeah, I think that easy. And then close it. So let's display this right here, so you can get an idea what we're talking about. Right here of the show. Okay, so I'll run it. Okay, you can see this is what I'm talking about, right? I'm now outputting everything. Okay, so what you need to understand is for each of these let's say, okay, we basically have product df, right? And the product df has id, so it's going to take the first id and basically kind of doing some iteration, right, under the hood. So 1001, which is the product id, and it's basically going to take so it's going to take this array, right? So you have, let's say you have array from 0, 1 to 3, right? So it's going to explode it as 0, 1, 2, 3, right, for each of the product ID. And then so here we have product A, right? So for product A, it's going to take explode it, right? And product A is 0, product A1, product A2, product A3, and another product you have is product B. So it's going to take product B0. Like you can use the ID as example, right? 102 0, 102 1, 102 2, 102 3. So when you are joining, right? So I think it's better if I just display a different data frame with column. Let me call it right sort. That would be. So I'm going to concat this ID, right? This ID called ID, then leads underscore, and then so I'm going to concat it with this explode call, right? So that would be call exploded exploded call. Okay, so now you can see what is happening. So I'll just run it again so you can see. Okay, so this is the data frame, right? So so we have 101, which is product A. So when you explode it, you have 0, 101, 0, 101 underscore 1 for 101 underscore 2, 101 underscore 3. So when we are joining it, so what we're going to do is, instead of using this ID as the key, we're going to use right sort as the key. And for the first table, we're going to use the sort as the key. So that would be that means we're going to join the two data frame where left sort equal to right sort. So the data will be more evenly distributed then. So so let's say what should I call it, by join df2 equal to so the first one we need to join is sort df, which is the one we have right sort on, I mean left sort on. So that will be sort df dot join, and then we want to join right df, and so the key will be sort df dot column. The column name is going to be left sort, and so where left sort equal to right df dot column. The column name is right sort, which is this right sort. So right sort. The join tab is going to be left outer, and I want to order it by the sort, right? So I can order it by left sort or right sort, but after you've done this, you have to drop the sort and the ID. You can only have one ID, which is probably product ID in this case. And then let me just drop the ID. drop id, and copy that one. Instead of count df, I'm going to use join df2, and so I'm going to check the size. And for the first one as well, the one without sorting, I'm going to use a join df just for comparison's sake. Join df. So I'm going to print the size as well. It's size, alright, and so I think that is it. What I can do is now is run it and see what comes next. Okay, so it's running one. So this is the, oh wow, this is awesome, right? As you can see, we have this instead of having okay, let's go back to the first one, right? So like instead of having this 15 in the first partition, 15 record in the first partition, 9 record in the second partition, 106 record in the third partition, and 14 in the last one. Right now, what you can see here is after we've applied the sorting, right? First record has 33 partitions, second 36, third 36, and the fourth has 39 record. You can see how well distributed the data are right now after we've applied the sorting. And let's go back to the maybe I didn't show the join df. Maybe I should have. I made the join df after the sorting has been applied. So join df to join df dot show. So I need to compare this, the first show with the second one. So join df dot show, join df dot show line 28, and join df 2 dot show line 49. Okay, let's run it. Okay, so it has finished running. We have 38, 36, and 68. In this case, what you could do is basically you may try to use like a partition or coalesce to basically instead of having 4 partition, you can use coalesce to reduce it to 4 partition, and this last one will probably be distributed across the rest. Anyway, what I want to check is line 49 and line 28. Let's go to this part UI. Okay, line 49. Okay. As you can see, right, we've got 60 millisecond after the sorting technique has been applied. Let's check the one when we have no sorting technique. Okay, it's line 28, and we can compare I think 60 millisecond to 61 millisecond. The number of time it's taken. So if it's a very big data, you can see it's going to be like massive difference. And we can also compare the count for each of the when we apply counts. So this one is taking 0.4 second, and so without sorting, let's see, 0.5 seconds. So you can see the difference between the two. After the sorting is applied, the time decreases significantly. But you can't see much of it because the data is quite small. Or if it's millions of records, you will see the massive difference between the two. So Yeah, I think that is it for this video, guys. Thank you for watching, and I hope you've learned something here. And so that is basically how you can apply sorting technique in Spark. Okay, I hope to see you in the next video. Right? Take care, have a lovely day. Bye. Okay, before you go, don't forget to subscribe, hit the like button, and leave a comment if you want to see more videos like this. Thank you. Bye.